All right, guys, so today we're looking at section 4.1, which is on congruent figures. So we're starting a new chapter. We're going to look at congruent figures. And honestly, we're mainly going to be looking at congruent triangles in this chapter, but there's other things that are congruent as well. Please keep in mind, I would encourage you to watch the lesson video that I made for this module before you watch this one, because I'm going to just highlight the key ideas. And hopefully, there we go. All right, so here is our main theorem for this section. And it's the definition. It's not a theorem, I'm sorry. It's the definition of congruent figures. It says congruent polygons have congruent corresponding parts. They're matching sides, they're matching angles. When you name the congruent polygon, you must list the corresponding vertices in the same order. So, for example, you see this polygon over here. This is A, B, C, D. And polygon over here, this is E, F, G, H. I am telling you that angle D has to be congruent to what? Angle H. Angle D, right here, has to be congruent to angle H. Has to be. You know why it has to be that one? Because that's the corresponding part. If you look at it, this green angle and that green angle. By the way, what's the corresponding part for angle B? Angle F. So if you look down here at angle B, where's angle B? There's angle B. Guess what it has to be congruent to? Angle F. Now, one final thing I'm going to mention about this before I move on to the next slide. Look at segment AB. Segment AB, that's this guy right here. Which segment in this polygon is it going to have to be congruent to? Well, it has to be congruent to that exact same corresponding side. Guys, if you understand what I just said here, that the corresponding angles are congruent to the corresponding angles, and the corresponding sides are congruent to the corresponding sides, when the polygons are congruent, that's basically the entire lesson. That's what you need to know. Now, I'm going to put a little emphasis on this part down here, because I'm going to talk about that more in a minute. Because notice what it says here. When you name congruent polygons, you must list their vertices in the same order, and I'll talk more about that in a second. Okay, so let's go to the next slide. Let's look at an example. So these two polygons are congruent. Now let's see if you can do what I just suggested. So that means that A, B, C, D has to be, now here's where we have to be careful. We have to put things in the exact same order. What letter in this guy is going to have to go first? Has to be F. If you put anything other than F, it will be wrong. What letter has to be next? G. What about next? H and I. And guys, I know that seems so obvious. And the reason it's so obvious is, I mean, you can see this is the one on the left, that's the one on the left. This is the one on the top, that's the one on the top. Sometimes on problems, though, they'll make one of these shapes, they'll like turn one of the shapes a little bit to be tricky. So be careful, okay? So now I have a question. Ishmael.
C.
Angle H has to be congruent to what?
C.
Angle C. Do you guys agree? Now notice something. Since I were forced to list corresponding parts, here's angle H here, right? And it's the third letter over, correct? The congruent statement then tells us that angle C has to be the angle that it's congruent to, because they're both the third one over. Does that make sense? So this is actually really easy if you follow the convention. Now I'm going to ask a harder question. Let's go with I think I've called on everyone now at this point. Tomas, can you tell me which side has to go, or which side has to be congruent to DA, segment DA, IF? Okay, are you guys with me on this? Do I need to do more? Now, guys, how many corresponding parts are there? Should be many, sorry. How many corresponding parts are there between these two guys?
4.
Not 4.
8.
8.
Oh, the sides.
You got to do all 4 angles and all 8 sides. I'm not going to do all of them, but we could. If these two guys are congruent, if this polygon is congruent to that polygon, then all 8 of their corresponding parts are congruent. Everything is congruent. Now, what we got to be careful is, can I say that angle A is congruent to angle H? No. Now, could it be in a problem where that's the case? It could be, like if this was a square or something. But in general, this is, I don't know. However, A does have to be congruent with angle F, correct?
Yes.
So what does the measure of angle A have to be then?
45.
Well, angle F is 45, so angle A also has to be 45. I keep wanting to go forward on my PowerPoint in this one. Okay, so here I'm not giving you a picture at all. And I'm telling you that this triangle is congruent to this triangle. Okay? Anthony, what angle has to be congruent to angle C?
H.
Correct. Why, Anthony?
Third one over.
Correct. So this was the third letter here. This is the third letter here. So that has to be true. Okay? Vaughn. Ooh, I'm going to ask a hard question. Let's see if you can get it. Segment AC has to be congruent to what?
H.
You got it, buddy. I think. Are we okay on this?
Mm-hmm.
Now listen, this right here is called a congruence statement. And you can probably guess why it's called a congruent statement, because it says that two things are congruent. No big surprise. The order in which you put those letters is very important. Okay, the order in which you put those letters is very important. Okay, last thing for this lesson is the following. It's called the third angles theorem. Here's what it says. If two of the angles of one triangle are congruent to two angles of another triangle, then guess what has to be true about the third angles? They have to be congruent too. So think about it this way, guys. If I told you that this angle here was 60 degrees, and I told you that this angle up here was, let's say, 40 degrees, and then this over here was 60 degrees, and this here was 40 degrees, would you agree that two corresponding angles are congruent? Does it make sense then these two here have to be congruent too? It does, right? Because what do all three angles of a triangle always have to add up to? They always have to add up to 180. If these two guys are 100, then this angle over here has to be 80, right? If these two guys add up to 100, guess what that guy has to be? 80. So this is called the third angles theorem. I'll say it again. If two angles of one triangle are congruent to two angles of another triangle, then their third angles are congruent. In other words, in this case, angle C is congruent to angle F. Okay, let's do one more example. And actually, I want you to think about this for a second, okay? I want to know, is angle S congruent to angle P? And I'd like you to prove it. So I want you to think about how you would prove that, and I'll give you a hint. You're going to want to use this theorem, the third angles theorem. I'm going to pause the video here. I'm going to give you just a second here to think about this. Let's pause this. All right, guys. So we've got our proof set up here. We're trying to work on this. Why is angle T congruent to angle Q? Because they're both right angles, right? So I might just say right angles are congruent. In fact, they're always congruent, right? And why are they always congruent? Because they always measure 90. Would you guys agree with that? That makes sense. Now, Vaughn helped me out with the really tough one, and he pointed out that this angle here, angle SRT, and angle PRQ have to be congruent, right? Why again? Vertical angles. Vertical angles are congruent. That's always true as well. Right angles are always congruent. Vertical angles are always congruent. So why is angle S congruent to angle P then? Why is angle S congruent to angle P? By the third angles theorem. And the third angles theorem again states the following. If two angles in one triangle are congruent to two angles in another triangle, we just showed that one angle and then a second angle in those two triangles are congruent. Therefore, the third angles have to be congruent. Does that make sense? That's actually one of the kind of easier proofs. Would you agree? Okay. I'm going to go ahead and stop the video here.